First, let us look at the problem. Water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter into cuboidal pond which is 50 meter long, 44 meter wide. In what time the level of water in the pond rise by 21 centimeters, and then find the amount of water in cuboidal tank can hold is the question. So this find the amount of water in the cuboidal tank is nothing but the asking volume of the cuboidal, So this thing I think you can get it just by reading the question itself. So before starting this problem, we have to consider few important things which is very important to solve this problem, and that is this. What are the key things to keep in mind before solving this problem is: 1. Units has to be same. That is, if there is meter, you can convert it into centimeter, or if you want, you can convert centimeter into meter also. But remember, the whole problem you read, whatever length has been given, it should be in the same unit so that it will be correct method to solve the problem. Here one we see that 21 centimeter is there. The 21 centimeter you can write it as 21 into 10 to the power minus 2 meter or 0.21 meter, or conveniently 21 by 100 meter. This is very comfortable. 21 by 100 is very useful for us. Similarly, 14 centimeter can be written as 14 by 100 meter. Now I am converting all centimeter into meter. Similarly, 7 centimeter. Actually, if you read the problem, there is no 7 centimeter given directly. But since they have given the diameter, we know that the radius we need to calculate for the cylinder. Just before doing the problem itself, I am converting the diameter into radius. That is 14 centimeter means that is nothing but 7 centimeter or 7 by 100th of a meter. So one unit is problem solved. Second one is, and there is another unit, that is what is called 15 km per hour. That is the speed of the water. Here it is in the kilometer. Now we will put it into meter. So how to put it in meter? 15 into 1000 meter per hour. Please note that I have never converted hour into seconds because that doesn't come into picture anywhere. That our time has come only once. So therefore, just you convert the length into meter is enough for this case. So this is nothing but 15 into 1000 meter or 15,000 meter. Next one is, second one, if you read the problem, you encounter that the height of the cylinder itself is not given. That is the main problem that any student will first get struck into it. So to understand that, what you do is, the speed of the water in the cylindrical pipe is given. So at what speed it is being flown? It is flowing at the rate of 15 km per hour. So therefore now what we do consider is, we will consider the water is flowing in the cylinder pipe for 1 hour. For 1 hour means what? We will consider it as 15 km height itself. So in case of cylinder, the speed is given as 15 km per hour. From this, you draw the data, that is the height of the cylinder, as 15 km. That is 15 km or 15 into 1000 meter. That is what we have done here. That is 15,000 meter. Next, the real problem is, this is the last answer, that what is required in the question. Time is asked. So to find the time, you have to follow the 3 steps. First, we will find the volume filled in 1 hour in the cylinder. So this is the key. So for this, height is already we have taken 15,000 meter. The height is 15,000 meter. Second one, find the volume of the cuboidal tank. That is, we know that is nothing but L into B into H. Now what we get is volume of the cylinder we get and the volume of the cuboidal tank we get. Now we will divide the volumes to get the time. Now we will divide the volumes to get the time. So this is more important data that you have to think before attempting this problem. Now we will draw pictures, convenient pictures for this. As we know, the solution is like this. The cylinder is of height we have taken 15 kilometer or 15,000 meter. That is the height of the cylinder. Next, the diameter is given as 14 centimeter or 0.14. Now we will convert it into radius. The radius becomes 7 by 100th of a meter. This is more comfortable for calculation. Therefore, we consider this. Next one, by using this, we will find the volume of water flowing in the cylinder for 1 hour. So what amount of water we get at the speed of 15 km per hour by this cylinder. So therefore, to calculate this, the volume of the cylinder water filled in 1 hour, we know that V is equal to pi into R square H. Pi is 22 by 7. R square is, we have taken 7 by 100, as in this case 7 by 100 into 7 by 100 into H, that is 15,000. That is what we have considered here. For 1 hour we are considering. Therefore length we will deem, that 15,000 meter. So therefore we will put it as 15,000 meter. Now we will do the simplification. Next, 7 ones are 7 ones are. Next, these 2 zeros will go, these 2 zeros will go. Similarly, 1 more 0 and 1 more 0 will go. Now what is left here is, here it is a 10 and it is 15 and it is 22. If you want 2 5s are 10, you can cancel 2 11s are. Next one, 5 1s are, then 5 3s are. So what is left here? 11 into 7 into 3 over 1. 11 into 7, that is 11 77 ಇಂಟು 3, 7 3 21 2, 3 7 21 231. So that is nothing but 231 meter cube, because in the whole thing we have converted into meter. So this is the volume of water what we get through the cylinder for 1 hour when the water is flowing at the rate of 15 km per hour. Similarly, if you consider the cuboidal tank, the one unit is 50 meters and the width is 44 meters and the height is 21 centimeter. We have converted 21 centimeter into 21 by 100th of the meter. Now what we do? We will substitute the values. Length is 50, breadth is 44 and height is 21 by 100. This 100 because of our conversion. Next, if you do the simplification, 51s are, 52s are you get. Next, 2 1s are, 2 22s are, 2 22s are. So therefore it is nothing but 22 into 21 is the required volume. That is, ಅಲ್ಲಿಗೆ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, 2 2 2 2 4 ಪ್ಲಸ್ 2 4 2 4 2 6 462. So this is 462 meter cube, 464 meter cube. Just look here, 1 ಅವರಿಗೆ 231 ಮೀಟರ್ ಕ್ಯೂಬ್ ತುಂಬುತ್ತೆ. ಆದರೆ 462ಗೆ ಎಷ್ಟು ಗಂಟೆಲಿ ತುಂಬುತ್ತೆ? ದಿಸ್ ಈಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಡಬಲ್ ಆಫ್ ದಿಸ್. ದೇರ್ ಫೋರ್ ಟೈಮ್ ಈಸ್ volume of cuboidal over volume of cuboidal plus volume of cylinder. So this is nothing but 462 divided by 231. 231s are 232s are. That is 2 hours. So the time required to fill the cuboidal tank is 2 hours is the required answer.